I want to start with a Slido after the break. So this is the program for the Slido quiz. So here you can see we create a very simple function called update value here. And the parameter is a pointer variable. And what this function wants to do is to change the value of the pointer variable point to, and then assign 10 to it. So here, what you need to think about is what should be passed here to make the output of this line to become the value of num is 10. So what should we pass here? What kind of argument we should put it here to make this program run successfully? Okay, so let's start. Oh, now, okay. Let's open the Slido and then try it again. Okay. So what should we put in the argument for the code of the update function so that you can correctly update the value of num to 10? Okay, so again, let's wait until we have 30 submission. Okay, we need two more. Who will be? Okay, great. Very good. So most of the people choose the correct answer. So yes, we need to pass and NUM. So, but I still notice that some people choose this one. So let's quickly review the program we have here. So the program we have here, so what we need to choose is what we should put it here, right? So first, you should notice that the parameter list, the parameter for this function is a pointer variable. So what value can be stored inside the pointer variable? That is the address, right? And the address should be the address of the integer type, the object with integer type. So that is why we need to assign the address of num to the function here. So one way to get the address of NUM of non-integer variable is to apply address operator. So that is why this is the correct answer. This is incorrect because num itself is not a pointer variable. Indirection operator can only apply to pointer variable. So if you apply if you apply indirection operator to ordinary variable, it will cause the compilation error, or you will just, I believe most of the time you will just get the error message from compiler. Okay, so one big topic after the break is that I want to introduce how to use pointer with array, because we can actually play array using pointer. We can have a lot of different use. So the first thing is that actually the pointer can point to array elements. Okay, so let's assume that if we have an array called A, and we can get the element I of A using this, right, AI, and we can apply the address operator to AI to get the address of the element I of A. So we can get the address of this element here. We can get the address of A3, A0 here. And it's useful to design a function to return a pointer to one of the elements in array. For example, in these functions, what this function wants to do is to return a pointer to the middle elements of array A, and let's assume that A have an element. So we can write the function like this. We can have the name of the function, and the input of the function is A, and the length of n. And since what this function wants to do is to return the at the middle element. So what we can do is to return the address to the middle element, because as long as we have the address to the middle element, we can access to the middle element using indirection operator. So that is why the return type of the function is int and star symbol here to indicate that what this function will return is a pointer point to the integer object. And what I return is to first I calculate the middle element using the expression here. So I just get the middle point of A, and then I use the number as the index number. So here I have A here, and this is the middle element of A, and then I just return the address of this middle element. So for the pointers, so one special thing in C about using pointer to array is that C allows us to perform pointer arithmetic when the pointer points to array. So the arithmetics in Chinese called 运算. For example, addition, subtractions are all belongs to arithmetics. And this is an alternative way. This is another way of processing array in C. So we can actually use pointer as the array index. So we can use index to get the element in the array. We can also use pointer to get different elements in the array. So through the later slide, you can know that in C, the relationship between pointer and array is pretty close. So if in the advanced C programming, you can use pointer to do more flexible manipulation to the array in C. So first, let's check out how we can use pointer with array. So first, just like we mentioned in the previous slide, we can use a pointer point to one of the arrayed elements. So in this case, I have an array called A, and it has 10 elements. So it will range from 0 to 9. And then we have a pointer variable called P, and we can assign the address of A0 to P, so we can make P point to the A0 here. And then after we make P point to A0, we can access A0 through P by adding indirection operator to P. So we can assign 5 to star P. So star P will become the object it points to, so it will be A0 here. So that is why you can see we have 5 inside A0 in the 0 element of array A. And if P points, so if in your program this pointer variable points to one of the elements in the array A, other element of A can be accessed by performing pointer arithmetics on P. So if I want to make P point to A1 instead of A0, I don't need to write another line called like P equal, I don't need to write another statement that I just write down A1 and then address operator assign P. I can use a more simple way to make P point to A1 instead of A0. So that way is called pointer arithmetic. So C supports three types of pointer arithmetics. First, we can add an integer to a pointer. We can subtract integer from a pointer. We can even subtract one pointer from another pointer, as long as all the pointers is point to the same array. So let's check out how to do these 3 types of pointer arithmetic. So first, again, we have the same setting here. We have A, we have P, and we make P and Q. So first I just make P point to element 0 of A, and I can actually add an integer j to pointer P, and by doing this, I can create a pointer point to element j places after the one P point 2. For example, so you can think about this P at j will become this index here. So we can get a 0 at j element here. So depends on the value of j. So let's use this figure to have a better understanding about what happened here. So we have A here, we have P, and in this case, P points to A2. So P points to A2 here. And we can add 3 to P and then assign the return value of this expression to Q. So we can see that P, if we add 3 to P, we make P point to this place. So we can see if we just add 1, we can get the address of the element here, because 2 add 1 is 3. If we add 2, P add 2 is 4. Then the P add 3, that means that we can get the address of A5, and we just assign this address to Q. So Q itself is also a pointer variable, so that is why when we assign the address of A5 to Q, we can make Q point to A5. And we can even move the place where P is point to, we can make P point to another element in A. So we can add 6 to P, and then we assign the return value to P, because here we use the compound operator. So P moved from here to 1, 2, 3, 4, 5, 6. So the P after this line will point to 8 here at this point. So this is the first type of pointer arithmetic. So we can add the integer to a pointer, and the return value will be the pointer to the element j places after the 1P is point 2. So the return value will be the address of the new elements in A, and then we can assign the address back to the pointer variable. So we can make the pointer variable point to different elements in A. And similarly, the second type is subtracting an integer from a pointer. So we just perform the same thing, but just in this time, we just move from right to left. So here we have P, and now firstly we make P point to 8 here, add this element here. And in this case, we just subtract 3 from P, and then assign the return value to Q. So if we subtract 3 from P, we just move P from here to 1, 2, 3 to here, and we can get the address of A5 here, and we just assign the address of A5 to Q. So that is why we can make Q point to A5. We can also do the same thing for P itself. So we just subtract 6 from P, and then assign the updated value to P. So after this line, P will just point to A2, so we can move the place P point to from here to A2, because 8 subtract 6 is 2, right? So that is why after this line, P is point to A2. So the final type of pointer arithmetic is to subtract one pointer from another pointer. So one pointer is subtracted from another's. The return value, the result, is the distance between the pointers, and the distance is measured in array elements. So you can think about the return value is how many elements between these two pointers. So let's check out the example here. So in this case, we have A, we have P, I have Q, and firstly I make P point to A5, so P is pointing to here, Q point to A1, so here, and then I just subtract Q from P, and we know that between P and Q there's 1, 2, 3, 4, there's a 4 element array away, right? So the return value of this expression will be 4. We can also subtract P from Q, and because P have a larger number of index, so that's why the return value of the second expression here is -4. And you can store the return value to one integer variable called I in this case. So the value stored inside I will be 4, and then after this line, the value stored inside I will be -4. So the final type of pointer arithmetic is to help us to calculate the distance between two pointers. And this kind of pointer arithmetics have something we need to pay attention to. So please don't do the following two things, because these two things will cause undefined behavior. So the first is that we cannot perform the pointer arithmetics on the pointer that is not point to an array element. So the pointer arithmetics only success when the pointer variable is point to an array. So if the pointer variable just points to one integer variable, then you cannot use any of the pointer arithmetics here. So first you need to make sure that the pointer is pointing to an array, then you can use pointer arithmetic. And the next thing is that when you want to perform this one, you want to subtract one pointer from another. In this case, you need to make sure that both pointers are pointing to the element of the same array. So if one pointer is pointing to array A and another is pointing to array B, you cannot do the pointer arithmetics between these two pointers, because these two pointers point to different array. So this is the second thing you need to pay attention to. So please make sure you fulfill the requirements before perform the pointer arithmetic. And finally, we can actually compare pointer using relational operators and equality operator. And however, these two operators can only use for the pointers that point to the element of the same array. So we can only apply relational and equality operator to the pointer that is in this case, that's Q and P are point to the same array. So here is a quick example about how we can compare pointers. So the outcomes of this comparison here, so here I just compare P with Q. The outcome of this comparison, how can I know P is larger than Q? So we can judge from the relative position of the two elements in the array that this two pointers point to. So in this case, P is pointing to A5 and Q is pointing to A1. And we know that so the index number of A5 is larger than A1, right? Because 5 is larger than 1. So in this case, P is larger than Q. So the return value of this expression will be true. So we can print out the value here. So that is how we can apply the relational and equality operator to the pointers where these 2 pointers point to the same array. And before the break, I want to introduce some useful online tutorial here. So maybe some of you already heard about the CS50 from Harvard University. So it's a very, very good, and I would highly recommend. This is a very great online tutorial, and it's from Harvard University, and they just release all the things online, and they use a very creative way to teach programming design. So they have a lot of online video here, and you can check out the online video. They have a slide, they have a subtitle, have a lot of things. So super recommend you can check the tutorial here. And also that is why we want to use English in this course, because if you know how to use English to learn programming design, you have a ability to take all this course from the top tier university across the world. Okay, so this is the tutorial I personally recommend it. It's super cool, and here is the YouTube video from this course to talk about pointers. So I will also recommend you to check out this video after the course, and I believe you will have a deeper and better understanding about pointers. And that is actually all for today, and that's all. Thank you for coming.